Let us have an example of conditional probability. Suppose two cards are drawn from a normal deck of playing cards. Let E be the event that the second card drawn is a king, and event F will be the first card drawn is a king. We're asked to find the probability of the following. The first card drawn is a king. Both the first and second cards drawn are kings. The second card drawn is a king given that the first card drawn is a king, and the second card drawn is not a king given that the first card is a king. Pause the video and try to see if you'll be able to figure out these probabilities. Alright, so let's now solve these probabilities. Of course, as usual, let's first note our sample space, or at least how many possible outcomes we have. So suppose two cards are drawn from a normal deck. So that would mean our normal deck will consist of 52 cards. That would mean that our sample space now would be, you first draw a card, so that's 52 possibilities. Since we did not say that the card was placed back, we will not. So after that, the second draw, there are only 51 possibilities. By the fundamental principle of counting, we have a total of 2,652 possible outcomes, and we would not want to list that. First, let's now find the probability that the first card drawn is a king. So, we would want to know in how many possible ways we can do this. So, that's actually event F here. So, first, event F. If the first card drawn is a king, that would mean you have 4 possibilities. The king of spades, the king of clubs, the king of hearts, or the king of diamonds. And that's all we need. The second one can be any of the other cards, which would mean that you have 51 other possibilities. It already includes the 3 other kings that you did not choose. It can be any other card. So by the fundamental principle of counting, this would actually be 204 possible outcomes. Therefore, our probability of having the first card is king would be 204 out of 2,652 ways, which would be, in lowest terms, actually, they don't have space, I'll just write it here, which is actually equal to 1 out of 13 chances that the first card that you will draw is actually a king. Now, what if we want to find the probability that both the first and the second cards drawn are kings? I don't have space here, so I will probably scroll that down here. So number 2. Both the first and the second drawn cards are kings. So that would mean I'm getting the probability of F and E. First and second drawn cards are kings. Probability of F and E. So, both cards I will draw would be kings. So I have 4 possible outcomes of drawing the first king. And when I draw, I have 3 possible outcomes because I already drew the first one. So via fundamental principle of counting, I have 12 possible outcomes of both drawing this one. So therefore, the probability of drawing both the first and the second card would be kings, would be probability of F and E, or it's pretty much the same as writing the probability of E and F, would be 12 over 2,652, or 1 in 221 shots. 1 in 221 chances that you're both going to draw kings in your first and second draw. Now, the third one, the second card drawn is a king given that the first card drawn is a king as well. or in symbols, the second card drawn is a king, so that's the probability of E given F already happened. So we can solve this probability in two ways. First, we know its formula. So its formula would actually be the probability of E intersection F over the probability of F, which we already solved actually. That would be this one, 1 over 221 over 1 over 13, which would give us the probability of, in its simplest form, 1 out of 2,873 chances. So the probability that the second card drawn is a king, given that the first drawn card is a king, is 1 out of 2,873 chances. Oops, wait a moment. I think this is wrong. Not supposed to be 1 over 2,873, but actually just 1 out of 17. Sorry about that. So there's actually 1 in 17 chances that the second card drawn is a king, given that the first card drawn is a king. So another way of thinking about it would be we know from our analysis in our first example that we can get the intersection of the two events, which is 12. I'm going to just use it also on a different color. This one here, probability of E given F, is actually this one here, the fact that both first and second cards drawn are kings. So there are actually 212 chances of that happening out of the fact that 204 chances or outcomes wherein the first card drawn is a king. So instead of a sample space of 2,672, we'll just get those 204. So 12 over 204, which will also lead us to 1 over 17. So you can either follow the formula of the definition or just think about the fact that if the condition happened already, then the condition in the first event's intersection is those outcomes that you want out of the number of outcomes of the condition, which is also essentially this one, but written in terms of probabilities. Now, what if we want the second card is not a king, given that the first card is a king? So let's place that down, and I'm going to use a different color here. The probability that the second card is not a king, so that's a complement, out of the first card is a king. So first, if we're going to imagine the scenario, we have the second card is not a king, given that the first card is, or that the first card happened, would be this. So if the first card is a king, that would be 4 possible chances of happening. But if the second card is not a king, then that would actually be the 52 cards minus the 4 kings will just be 48 other possible outcomes. So that would give us a total of 192 outcomes of the second card, not the king, given that the first is. So therefore, the probability of this happening, only the probability of the second card is a king and the first card is a king, let's write that down, would be 192, oops, I forgot the equal sign, would be 192 over 2,652. But actually, we would only need this number. So, for this probability, following this one in the orange thinking that we had here, we're going to have 192 possible outcomes of not getting the second card king while the first is, over the total number of outcomes wherein you both the total number of outcomes that the first one is actually a king, which will be 191 over 204. 192 rather, over 204, which in lowest terms is actually 16 over 17. You can try the formula for conditional probability, you're still going to get the same answer. Now, have you noticed something? The probability of the second card being a king, given that the first is a king, and the probability that the second card is not a king, given that the first one is. Do you see the relationship? We're going to figure that relationship out in the next video.